Hello everyone, my name is Sungkwang Mun. I'm a computer engineer in Center for Digital Systems, and I'm here for talking about Christian science as a part of Christian lectures. It's the fourth one. If you don't know me, I'm a father of two sons who goes to the Starkville Christian here in Yoga. And today's topic is scientific evidence for the young art. The goal of this presentation is tell you that science and faith can go together, and you don't have to necessarily, hate the science or the scientism over the Bible. So we can find some evidences that supports our belief in God and Bible. So you can go for the evil work without any problem with the current scientific finding that says all the universe is its own. Okay, let me first recap of what is a young Earth creationist view. So as a young Earth creationist, we believe in God and Bible, biblical accounts of six-day creation, and also historicity of a Genesis flood in global scale. And we question the evolution idea, such as cosmic evolution. That's basically the Big Bang, and the planetary evolution. That is, stars formed from gas cloud, which is not there's no evidence for that. So organic evolution, life begins from inorganic matters without any intelligence, God say. And macroevolution, and evolution, animals and plants change from one type to another. And lastly, the microevolution, variation from the within the kind. So among these five, only the microevolution within the kind is proved and observed. And at the same time, uniformitarian idea or naturalism is the one that also we question, especially found in the geological layer. So basically, the Christian science is an effort to apply a scientific method to discover how God created the heaven and the earth. So that's what we, in the previous meetings we talked about, worldview, and also the biblical understanding of the sin, death, restoration, its implication with respect to the art history, and also the last time we studied Noah's flood and the feasibility of the Noah's Ark. It can stay within the devastating situations. So that's what we covered. Now we're going to see a couple of examples that supports the earth is rather young than all the people said that all the universe is old. Before starting that, I'd like to introduce what we do in the daily lives for feed our family, and because that's relevant to one of the topics. So this is what I do, and actually this is what all the lecturers do. In some different materials, but we study all the materials using computer tools to find answers to some questions such as what is the damage mechanism, how it affects the strength of the material. Basically, we break things to find the better material. So if we find the mechanism, how it breaks, or how easily it breaks, or how difficultly it breaks, then we can make better material, like light and strong material. In order to do that, we have to look into very small things in the material. So do you know what is the smallest thing in the world, in the earth, that is observable through the microscope or something? Yeah, atom is the one, right. So we are looking at the atom, But it is a computer simulation. Computer simulation almost for free. We can just break things, right? Many times. So we use computers. For example, the polyplastic material. So we specifically is a polyethylene, the helmet, vest, or the cord. So that's made up of this kind of bunch of chains tangled. So it's a long, thin chains composed of a carbon and hydrogen. So it's called polyethylene. And if you look at this, is 500 nanometers, which is 100 times smaller than your hair strand. So it's a really small scale. And then even look at the smaller scale, we can see that the chains are entangled like this, and also there's some void, some space between the chains. And if you pull it, you can see, as you can see, we quantify the void within the chains, in relation to the damage, how strength the material is. So we found some relationship and put it in the equation and then run the simulation and find the better material. That's how we do. And the detail is chain is asleep or the chain itself is breaking. So those kind of mechanisms is in there. So we talked about the smallest scale is very important to find out the material properties. So that's a very important finding. And we're going to use the scheme to how do we measure the age of the earth. So this is outline. We're going to look at the 5 examples. 2 of them are radiometric, and 3 of them are geological evidences. Let's get started. So radiometric evidences. So in order to explain the radiometric dating, so I have to explain what is the radiometric dating is. So bear with me to explain some basic concepts. So how do we measure the age of the things on the Earth? So the scientist uses the radiometric dating, which is basically looking at some one material, a small atom, which is unstable by some reason. I'm going to explain later. But it becomes, because its state is unstable, it naturally becomes stable. It goes towards the stable state. So it takes some time. So the process is called radioactive decay. So it generates some heat when it becomes unstable to stable state. So the one maybe analogy is, and this process is spontaneous. So I'm going to explain for example. So everybody likes the popcorn, right? So popcorn in a bag. So you put in the microwave. How long do you put? What time do you put? Maybe 1 minute or 2? 2 minutes. Let's say 2 minutes. Okay. And assume that the popcorn kernel is going to pop all of them in 2 minutes. Okay. So then, how do you know half of the bag will be going to pop? Roughly 1 minute, right? Right? So half of the kernel is going to pop in 1 minute. So that's called because we don't know which kernel is going to pop, but we know that at some point, half of the bag will be going to pop, right? So that's called what we call half-life, and this is not exactly, analogically explains what's going on. So there are some dating methods, a couple of dating methods. The top one is organic material, carbon to nitrogen, and the others the bottoms are the inorganic materials. So let's explain. So the cosmic rays delivers a lot of protons outside of the Earth into the Earth atmosphere. It's like a billiard, and shooting a proton to the nitrogen, stable nitrogen atom, and then replace it with the proton. So it became stable, and it becomes C14. Usually 12 C12 is a stable atom, but it becomes C14, which is unstable, and eventually goes to the stable state by some time. But before that, the C carbon is joined together with the oxygen. It becomes carbon dioxide, right? So it's consumed by the animal and plants, right? So when animals and plants are living, then they are continuously consume those very little amount of the unstable C14 in lifetime. When it dies, and there's no breathing and respiratory system, so it gradually decay and loses the C14 content converted to the nitrogen 14, which is stable. So the wood and bones are the common examples, and so we measure that time the half-life, half kernels in the popcorn bag. It takes about 6,000 years to C14 to nitrogen 14. So use that method, we find out how long it's going to take to the age of the things in there. And by the way, the stable C14 is most abundant, so it's 99% in the air. When we talk about 10 to the 12, is the stable amount of the C14 in the air. That is a stable amount. I mean, constant amount. And like I said, inorganic materials, use a different methods, but it's very similar to this kind of ways to measure the amount and then interpret into the ages. So how we interpret mass to the age? So we need some information. So we talked about one cycle to become a half bag to be half cone is 6,000, and you can calculate, this is typo, but 14,000 and 17,000. You can see the cycles to how what amount it will remain. So if let's say the machines or human can detect a certain amount of C14. I talked about 10 to the 12 is the amount, and the current measurements only can detect 10 to the 16. So very small amounts that we can detect. So if we calculate this cycle, it goes only up to the 20 cycles. So which means 100,000 years the maximum years we can detect. Then how do we know this 5,000 years half-life? That is, we use the known data. One of them is the tree leaning. You can count the tree limbs for the age, and then some groups, right? Egyptian, such as Ptolemy area, and also Bible found in Dead Sea area. We know the age, and also the Egyptian king, which is all this. So you can see the data that we use to calibrate. So fitting this line over known data is up to about 6,000 years. So we don't know, if it goes beyond what data we're going to use. It's just use simple nonlinear lines to pass through, but whether it goes steeply down or it goes gradually goes to the 1,000 years, 100,000 years, that's a question. So the important assumption on this measuring age is that number of initial unstable parent material is known. So I said carbon 14 is in the air, 10 to the 12, compared to the stable C14, and also decay rate. So like the power of the microwave, 700 watts or 1500 watts, is constant over time. So that's another assumption. And also, you don't want to, another last assumption is that popcorn already popped, that does not go into the popcorn bag, or the corner is going out of the bag. So everything stays inside popcorn bag. So that's the last assumption. So whether it's true, that's a question. So using this method, assuming this is valid, so then rocks and fossils containing carbon, we talked about C14, abundant in the earth material. For example, coal, wood, shale, bone, marble, natural gas, CO2, plastic. We saw the example, all made up with the carbon. So we can measure this with this method. So the current measurements, as I said, up to the 100,000 is maximum. And if you know this kind of fossils and coals, and apparently it's a million years, then natural consequence or the expectation is no unstable elements within, right? So no C14 basically. So C14 net material. That's what we expected. But we group of researchers send the various materials over to the lab and measure the amount, and comes back with almost every material in the earth has the C14 content, which means it's we can set the max bounds. So everything is within 100,000. So I mean, on top of that, the line is only up to, it's a circulation regime, so interpolation is only up to the 6,000 meters. We don't know whether rate has been changed or actually the exponential function is correct. That's questionable. So anyway, even if we believe that is true, that sets the bounds of the earth of the ages is 100,000. So what about the inorganic measuring methods? So people use potassium, which is a very common material. By mass, 2.4% in the continent is existing. So using that, we can measure conversion of the potassium into the argon from the igneous rock. So quickly solidified from the lava, and it becomes, because of a lot of energy is coming from the lava, and it captures everything in the rock. And then anything slowly decay into the argon gas, there's no way the gas to escape. So it is captured, we can just break it and then measure the amounts. That's how we measure the ages from the rock. So we have some standard from the textbook. Is here, is the Jurassic period, 65 to the 248 ages. But group of researchers and try to extract, it's a literature review. So looking at a lot of literatures from the various locations, and then we sample from each individual known geological columns, and then measure the amount, and then translate into the years. You can see that one-to-one, it's not one-to-one matching. It's almost inconsistent data. One of them is ranging from between 1 million years to the 10 million years. So this is commonly found if you just do the measurements of the recently volcanic activity and then getting the igneous rock and then put it in the laboratory to measure the years. Easily becomes billions of years. So, some cases it's trustworthy, but many cases it's not. So, it's a common examples that all is Earth. All right. So next is the geological evidences. So every year, by rains and winds, it erodes some of the parts of the countries and then transports and deposits in under the ocean. So that's the amount of the 20 billion tons per year. In the bottom of the ocean, there's very strong plate, lava, solidified lava plate. So we can easily measure this amount of mud every year. And the only mechanism that remove the mud from the ocean is a subduction. So pulling all the mud, some of the mud inside the earth. So we can calculate plus amount addition to the ocean 20 billion, and living amount is 1 billion tons per year. So remaining is 19 billion accumulated every year. You can easily back calculate how much amount should be accumulated if it's billions of years. People say that the 3 billion years as a period of time there's a subduction occurs. So then it's a huge amount needs to be accumulated at this moment, but it's not. As you can see, this is NOAA, the government website, revealed that how much mud deposit is there. So it's up to 20,000 meters. So only 20,000 meters is available. So that tells, if we account for the flood event transferring a lot of mud into the oceans, then we can easily say the max age of the Earth is 5,000 years. So next example is a sea, salinity of the sea. So every year sodium, income of the sodium is 450 billion tons per year, every year. And by many different activities, we take it out 120 million per year. So the scientifically, salinity is going to increase every year. Then you can calculate, how much or the current years with this steady increase of the salinity, how much saltiness should be in the water if the Earth is billions of years. So that sets up the max age of the 26 million years, but it's with the consumption of the constant rate of the salinity increase. So last example is the magnetic field of the Earth. So magnetic field is Earth is like as a magnet. And then we talked about cosmic ray to convert the nitrogen to carbon. So the cosmic rays are actually very harmful to the human or animal, the living creatures in the Earth. But this one is gradually decaying. So we set the half-life, we talked about half-life, it takes 1,400 years gradually decreasing. So until it goes, until it's completely gone, it takes 10,000 years. If you go back, and then if you increase the magnetic field more and more, the billions of years, and it becomes that on the Earth, we would be inside the microwave. So it's for the strong MRI devices. So it hurts the human bodies if the Earth is billions of years. So and I would like to mention that the creation scientist Dr. Humphreys predict this Earth became a magnetic field based on the records of the decaying magnetic fields. He's the only one to correctly predict the decaying magnetic field in the Mercury, contrary to the conventional scientists. So which is a very good examples for us as a creation science and maybe somebody that will become. And that's a really good extraordinary finding. So we took this kind of examples today. All of this example shows that the Earth is wrong. The Bible says, for in 6 days the Lord made the heaven and the earth sea and everything in them. But on the seventh day he rested. So he clearly said that he created the world in 6 days, in a very short time. And also, for thus says the Lord who created the heaven, I am the Lord, and there is no one else. So he is the only one who created the world. So we can have a straightforward understanding of the Bible, and we can have simply accept some scientific finding with some scrutiny questions and evaluations. But both of them can go together. So some of the findings I made this slide based on the Answers in Genesis articles. So you can go side. And the next talk will be given by Dr. Michael Murphy about the biology. So I think that's it. Any questions?
So if uniformitarianism claims that everything in the past works like it does now, does that mean they can't use that for macro?
So the question is, microevolution, uniformism, the relationship between the uniformitarianism to the microevolution?
Yeah, macro.
Macroevolution. I think it can be answered by the Dr. Murphy better than me, but I think there are some hurdles in the macroevolutions. For example, one of the good examples, having the baby in your mother womb. So the cell itself is a non-self. Baby is a non-self. It's not you. So you have to somehow protect the baby, but the body system, immune system should attack own body, own your non-self, because it can be treated as a virus or a bacteria. So who is resistance, mother and baby is a really tricky question. So how become, human or the reproductive system can evolve without resolving that conflict. So that is one of the really difficult questions in terms of macroevolution. It's not macroevolution, but like one species to even the existence of the species.
So can you
Yeah,
I'm sorry. So
Yeah.
can you talk a little bit, elaborate your question again?
So macroevolution, you said that species had to come from different kinds of species, and that's not happening today, right? So
Right.
They can't observe that. They have to assume that happened.
They call it, maybe it's a missing, maybe related to the missing link, chimpanzee to human. But it is the only a couple of examples. Not examples, but human-like animals are buried and found as fossil. We have to have much more to find the gradual change from the chimpanzee to human. But there's no existence like that. So only a few samples resemblance of either chimpanzee or to human.
Maybe I can give more detailed answer in my talk. Yeah.
Yeah. Any other questions?
Evan, I think you had a great question. You should ask that.
What do you think an unbeliever would find most persuasive from this presentation? And what do you think is the most likely thing an unbeliever would criticize from this presentation?
So they might have an answer because this is available on public for a long time. So conventional scientists, especially atheists, try to rebut some of the assert here. But I think it's everything is a belief system. So we are talking about the historical science. It happens once in history. So you can choose to believe, Bible and biblical account, straightforward understanding, just through the lens of the Bible, and this is quite feasible. Within 6 days and 6,000 years, there's no problem. There's some evidences to support that. I can just trust this. Maybe we can question later on the millions of years. I think the dark matter, in the space is also very questionable material. So, scientists actually don't know about everything in the universe, but they fit their theory over to the the phenomena, physical phenomena. So they have their own belief system. So it's called the scientism. So you can choose. I think that's what I can say.
I think Ethan also had a good question.
Excluding any form of theistic evolution, how important are differences between young Earth creationism and old Earth creationism?
Yeah, that's a really good question. So old Earth creationism is in between, naturalism and the creationism, because they believe that God is ultimately behind the scene to guide all the processes. So there's a spectrum. Even people believe that God uses a spontaneous actions or events to become a human eventually. But like last time, 2 weeks ago, there's some theoretical implication if we go for the older belief, because it's all biblical understanding, clear understanding is sin comes to the human, and the death follows as a consequence of the sin. But the older creationists cannot explain why the death comes from before the sin comes into the human world. I mean, they have to answer a really difficult question. But with this younger creationism, we can have just a straightforward understanding. I keep saying that it's very easy to understand. Sin, corruption, death, redemption, restored, and we become body of the Christ later on. So we become our original form. So in the young earth creationism, humans are originally a lot better than that. And we are going to become the restoration, full restoration when we Jesus Christ. So we are looking at the view, then so evolution is looking at this, humans as a drifting. The evolution is drifting. A few years ago, evolution is going upward. That we are kind of evolving, better person. But now they change their minds, and we don't know. It's random. It maybe become better, it become worse. But DNA degradations. All the research shows that our DNA over time is degrading. So we're becoming worse and worse. Our descendants says. Yes, sir.
What do you think is the strongest argument for creation?
Strong is argument
For creationism.
for creation. Strong argument for the creationism. Debate. Are you asking? Can you elaborate?
Well, what do you think is a very good argument for creationism? One of the best.
One of the best. I don't know. I think I picked some of them, some of the obvious ones that evolution cannot easily answer. So maybe you can try one of them from my presentation slide. And I like the carbon 13 dating. So it only supports the known data set. I think it gives a really accurate age predictions within known data set, like from the treaties to the Bible script, and any event that happens in between. I think it gives a really correct answers. So, I'm not sure I answer the question, but.
Hayes, I think you had a great question about mountains.
Yeah. So do you think mountains were smaller before the flood? Because in Genesis 7:20 it says the water prevailed above the mountains, covering them 15 cubits deep, which is about 22.5 feet. So does that mean that water was 22.5 feet over Mount Everest, or was Mount Everest like there? Because if, like, you know, if you have to climb Mount Everest, you have to have an oxygen supply. So does that mean like they could breathe when they were that high, like in the ark?
Yeah, I guess, we don't know what is the shape of the earth before and after the flood. So, and Bible clearly says that, all the earth is submerged under the water. And the planktonic, due to the radical events throughout the time, the subduction of all the continents would change, all the shapes of the earth very easily. So we cannot easily know where is that actually Adam is, or the pre-flood area is, because of the drastic change